I want to do a problem that involves calculating the percent abundances of isotopes. Oftentimes, you're just given the percent abundances and the masses, and you're asked to find the average atomic mass. This problem looks like it initially you don't have enough information to do the problem, and so it's one of the trickier ways that you can assess average atomic mass. So you have two isotopes here. One has a mass of 111.624 AMU. The other has 109.875 AMU, and the average atomic mass is 110.352 AMU. And you're supposed to find the percent abundance of each. So you know that the substance or the element has two isotopes, and one has a mass of 111.624. And the other has 109.875 AMU. And you are supposed to find the percent abundance of each of these. Okay, so you're supposed to find the percent abundance of each of these. And you're also given that the average atomic mass is 110.352. So what you have to do is say, because you don't have the abundance of each, you're going to have to call the abundance of one, say, X. And the abundance of the other, you're not going to call Y. You're going to say that because there's two isotopes, the abundances have to add to 100% or 1. So you call the abundance of the second isotope 1 minus X. Okay? So setting up your average atomic mass, you know that you multiply the mass by the abundance. So 111.624X plus 109.875 times the quantity 1 minus X equals the average atomic mass, which is 110.352. Okay, so let's distribute. Okay, give myself a little bit of room. Okay, so I'm going to have 111.624X, and then I'm going to distribute the 109.875 to the 1 minus X term. So that's 109.875 minus 109.875X equals 110.352. Okay, so now I will combine the like terms. So I'll subtract the 109.875X from the 111.624X. Okay, and that is minus, sorry, let me type that into my calculator again. I must have punched something in wrong. Minus 109.875. And that equals, so I get 1.749X, okay, plus 109.875 equals 110.352. And I got that from combining the like terms. There's an X term and there's an X term, and that equals that. Okay, so now I'm going to subtract 109.875 from both sides, and I'll get, I'm going to do minus 109.875, and then I'm going to do minus 109.875, and I'll get 1.749X equals, and punch this on my calculator, 0.477. And so now I'll divide both sides by 1.749 to get the x by itself. And so when I divide 0.477 by 1.749, I get x equal 0.273. And so that's going to be the abundance of this isotope. Okay, 0.273 is 27.3%. And then the other isotope is 1 minus x, or so 1 minus 0.273 is the percentage of the other one, which is 0.727, or 72.7%. So that's just a little twist on your normal average atomic mass problem.